All right, and welcome to Simple Debts and Investments. Now, we want to know what is an exponential function, since this is the thing that will primarily drive all of our learning. And so we can write out our parent exponential function as a parentheses b raised up to the xth power. In fact, this is why it's called an exponential function, is because there is an variable in the exponent. Okay, so we have this variable as our exponent. All right, now let's go ahead and label the parts of this function. This a value, which you see being multiplied kind of by the rest of it, this will always be our starting point. Or if we ever graph these, it will be our y-intercept, and that's very, very important. Okay, what about this letter b? Well, that is our rate of growth or decay. All right, and lastly, what about this exponent x? Well, this is actually going to be typically associated with time. Oh, here, let's use a different color. This would be typically associated with time. This is the, let's say, the number of times our exponent grows. So for example, if we're looking at something that grows over a year and it has kind of a monthly interest rate, well, then that x would be 12 because there's 12 months in a year. If we're looking at something that compounds once every hour, well, maybe it's 24. If we're looking at one day, there's 24 hours. So it's the number of times that our exponent grows or compounds, we could say. All right, guys, let's go ahead and take a look at our first example. All right, you open up the Wells Fargo Propel account. By the way, it's a credit card that I personally hold, and you immediately book tickets to fly to China for a vacation for $2,700. All right, so let's underline all of our important information, if we can. Oh, well, it would help if I was using the appropriate color. For $2,700. The card gives you a great deal. You don't have to pay any interest for 1 year. In fact, guys, a lot of credit cards will do this for you. They'll say, you know what, you don't have to pay any interest for the first 12 months, knowing full well that by the end of that year, you will have not paid off that card. You'll still owe money on it, and now they kind of have you hooked. But if you don't have the card paid off, then you're going to have to pay all of the interest. So how much money would you owe in interest if the yearly interest rate was 19.6%? This is pretty standard, and you had not made a single payment. Now, I want to first say that an example like this typically does not exist in the real world. You'll be forced to make minimum payments, but we're going to keep it very simple as we first learn this. And let's start with our function. F of x is equal to ab to the power of x. If I were to ask you what is our starting amount, well, you would say we made a $2,700 purchase. Okay. And if I were to ask you, well, what is the time? Well, we see 1 year. Okay. So we're just going to simply put a 1 up there. That's easy. And then it says, you owe interest at 19.6%. So the question to ask yourself is, interest at 19.6%, is that increasing the amount of money I owe, or is it decreasing the amount of money that I owe? And in this case, it is increasing. So here's how I'm going to tackle our rate of growth. We'll say, okay, we have 100% plus 19.6%, and this is 119.6%. Now remember, for our rate of growth, we have to take that decimal and move it 2 places to the left. And so when we go to plug this in, we'll write 1.196. Aha. And now we can take this and we can plug it in. And we can figure out how much money would we owe for the full year. Okay. And let's see. So I'll go here, go to our Desmos. Let me shrink this into the window. And we can say, all right, we owe, what do we say here? Oh yeah, 2,700. 2,700, and then we're going to write parentheses, and then our rate here is 1.196, and then we are going to close our parentheses, and we can push this a to the power of b, and we'll just type 1 in for this case. So how much money would we owe? We would owe $3,229. $3,229. And I believe it was $0.2. Now, I want y'all to think about this. I want y'all to really think about this. The real question you always have to be asking yourself is, what was the cost of the interest? I mean, by the way, this is the answer here, but think about this. If the original cost was $2,700 and you wound up paying $3,229.2, well, you actually wound up paying an amount of interest. You could subtract these, but the interest that you paid would be, what is that? $529.20. That's the amount of interest that you gave them. That's the amount of money you paid them for them giving you that loan. And notice that's only over the course of 1 year. All right, so what if you had held this balance for 3 years or 4 years or 5 years? You would wind up paying significantly more. All right. Oh, I'm sorry. This said how much money would you owe in interest. So actually this is the answer right here. My apologies, guys. All right, guys. Let's go ahead and move on to our second example. Okay, here's our second example. You purchase a house on a 30-year mortgage at a 2.875% annual interest rate. By the way, this is roughly speaking the rate that people are getting right now. And we'll look at this later on, but this rate is so low, it's actually encouraging people to go crazy buying houses because they can lock in the same monthly rate for the next 30 years. All right, and the price of this house would be $256,000. And let's imagine just a world that doesn't exist, where for whatever reason you can't pay your bills, and for whatever reason they let that debt grow and compound. Now, this doesn't happen in the real world, but we're learning this kind of at a very simple level. How much interest would you accrue by the 30th year? All right, let's go ahead and start out with our function. F of x is equal to a b to the power of x. Okay, now one mistake that I made in our last one was not changing the x value there. So we're going to talk about this over the course of 30 years. And let's see, our starting amount, our a value, is 256,000 times whatever the growth rate is to the power of 30. And let's kind of talk about the growth rate. We're saying it has an annual growth rate of 2.875%. All right, so that means that the amount of money we owe is increasing by that amount every year. So if I do 100% plus 2.875%, that's kind of nice. It's actually just 102.875%. Now we're going to move our decimal 2 places to the left, and that'll give us 1.02875. Now you might be thinking, Mr. Hastings, typically we don't go this far out for decimals. We usually round. When we're talking about exponential growth, it is very important that you get as specific and go out as many decimals as you possibly can. So 1.02875, and let's go ahead and see what this is going to look like. After 30 years, how much money would we owe in total? All right, so 256,000, parentheses, looks like 1.02875, and of course we'll close our parentheses, and we click this a to the b, and we're going to put in there for 30 years. And the answer is we're going to owe about $599,149. $599,149. $599,149.79. Okay, now this is our total. This is our total, $599,149.79. And remember, we want to subtract off our original value, 256,000, and this will actually give us our amount of interest. So 599,149.79 minus our original price, 256,123, and it looks like the amount of interest we're going to wind up paying is 343,149. 343,149.79. And this is our interest. Now guys, what is interest? Interest is money that you do not get to see. It's essentially money that you get and you immediately give. It doesn't go towards the loan. It doesn't help you pay down the loan. It's the price that you're paying to take out the loan. Think of the loan almost as its own commodity. All right? So over the course of 30 years, if you were to just take this out and never pay it down at all, you would be paying more than the price of the house itself in interest. All right, let's go on to one final example. We'll be talking about investments. Okay, here's our third and final example. You invest $1,000 into the stock VU. Now, VU stands for the Vanguard S&P 500. We're going to talk about this more specifically later on. And the investment grows by 10.8% every year. After 35 years, how much money will be in your account? Of all the examples we've talked about so far, this is actually a perfectly fine real-world example. Why? Because you could invest $1,000 today and then just never touch it. All right? And so let's see what this would look like. So we have f of x is equal to a b to the power of x. And here, we're going to let this grow for 35 years. All right? And our starting amount is $1,000. And we're going to raise this once again to the 35th power because we're going to let this grow for 35 years. Now, our rate of growth, remember, we're going to start at 100%. And since it's a growth rate, we'll still add 10.8%. And so we're going to have a 100, So we're going to say that we'll have 110.8% of the original value. And as a decimal, well, we see that that is 1.108. Okay, now let's go ahead and plug this into our calculator. All right, so let's see, we have here $1,000 times our 1.108 rate of growth. I close my parentheses, and I click the A to the B, and we're going to let this grow for 35 years. And I want y'all to notice that this amount is $36,215.26. 36,215 and 26 cents. And I want y'all to really think about this. What are we saying? We're saying that if you invested $1,000 today and you just forgot about it, well, 35 years later, that amount of money that you'll actually have is $36,215.60. And if we subtract away our original $1,000 investment, well, we come up with this. We actually grew our money by $35,215.60. Now let's see what the question is asking. It says, how much money will be in the account? So guys, according to that verbiage, this is actually the correct answer. But I want you to know that this is the amount that we grew by. And guys, this is exactly how investments work. We'll speak about this more in a couple of lessons, but there you go. All right, guys, very carefully read each question. Ask yourself, what is it asking for? Because the math is not difficult here. All right, good luck, guys, and I'll see y'all in our next lesson.